welcome back to an absolutely frigid Texas afternoon. That is a sentence that is pretty rare for me to say, but it is below freezing outside. It's like 25 Fahrenheit out there, which is like -4 Celsius, and that's brutal for Texas. But fortunately, here in the new office, it stays a little warmer than that. Even with the heater off, this room tends to not drop below about 50 degrees Fahrenheit, which is about, I think, 10 Celsius. That's still pretty cold though, so I've got a little heater that I'm using to help bring the room up to a more livable temperature. But to supplement that heater, I've been running the vacuum tube computer a bit because it has a lot of little vacuum tubes on it and they put out a lot of heat. So between the two of them, we're getting the temperature up to a more acceptable level. But speaking of the vacuum tube computer, well, Rin is a name that's been coming up a lot in the videos with the Centurion here, because I would say he knows more about the operating system and programming, Centurion Programming Language, than just about anybody alive today, and he's just been an absolute wonderful help. But Rin first reached out to me quite a long time ago with an emulator that he wrote for the vacuum tube computer, and I actually did an episode on that quite a long time ago, and it was awesome. We had my laptop set up next to the vacuum tube computer, and we were comparing the two of them back and forth, and it was just cycle perfect. It was an excellent emulator. But one of the things that made that emulator really unique was that it was written to fit within an 80-column, 24-row display. And well, it just so happens that 80 columns and 24 rows is exactly what the data terminal displays for the Centurion are. As a matter of fact, that is kind of the de facto standard for data terminals. And well, Rin did it that way because he ultimately wanted to see the Centurion emulate the vacuum tube computer. So a few days ago, he sent me a Centurion Programming Language file that was filled with code and said, hey, run this. And it was titled EMU, so I think that's pretty special. I took a look through the code, and yeah, it's definitely a vacuum tube computer emulator written purely in Centurion Programming Language. So I think it's time we spin this big guy up and get that code onto it, compile it into an executable, and see what happens, because I think this is going to be very cool indeed. So let's get this thing running. Okay, I've got the Hawk spun up. The Centurion is booted up to the D = prompt. We'll go ahead and type H1. It's going to do 3 quick RTZs, and it's going to load us into the operating system. It's going to ask me for today's date and then the time, which I'm just going to set to August 23rd, 1984 and noon. And then once it says CRT0 ready, we are all the way in the OS. And just to confirm that everything's working well, we'll type .sta. And there we go. Everything's looking fantastic. We have 256K of RAM. We can see there's only one CRT connected at the moment, and that's CRT0, which is this main CRT here. And I think it's time to start getting Rin's program onto this machine. And it's a very beautifully programmed emulator, but it is several hundred lines long, so we could do it the hard way by opening up Compose, which is the built-in text editor and is atrocious. It kind of gives me flashbacks of a horrible time every time I mention its name. But we have a couple of better options. Rin also thought Compose was atrocious, and he wrote in a new text editor for the Centurion called CED, or Centurion Editor, and that's what we're going to use today. Now, Centurion Editor, or CED, is fantastic, a lovely program to use, but I'm not going to go into too much detail about how he built it today, because I'm going to save that for a later episode where we go into a lot more detail on JCL, or Job Control Language, which is kind of like a second programming language for the Centurion. All we're going to do is just use it to dump a boatload of text in through a terminal emulator on my laptop. I have one of those USB to RS-232 cables hooked up, and it did require a little bit of wiring change to get it to work with the MUX card, but that was pretty easy to do, and now that it's done, we're ready to get started. So all I got to do is hit Control-C, and we can see it says CRT7 ready. If I type .sta here, we should get a status display. And yeah, there we go. We can see the second partition number is CRT7. That's going to be me. Now, it's interesting that it's CRT7 because that implies that there are 2 MUX cards plugged into this system. And if we look down there, yeah, there's 2 working MUX cards plugged in. We've sysgened it so that you can fit 8 terminals on this thing. It's set up for multi-user use. But it's only me, so I'm just using the second terminal here to dump text in, and we're going to do that using CED. So we'll do s.ced. We want the file name to be ZEMU. We want that to be on platter 1, and we want the output device to be CRT7, which is our current CRT. So go ahead and hit enter on that. We don't want to put it in any libraries. It's going to ask me saying that it's not found. Do I want to create it? Yes, I do want to create it. There we go. It built the file, and now we are at the main CED prompt. And I'm just going to hit A for append, hit enter, and it looks like we're losing some text here display on my terminal. That's really interesting. It should say dot by itself to end. Hopefully it copies over all right, though. We'll go ahead and give it a shot here. I'm just going to select the code here, do a Control-A, make sure that I end it correctly, hit Control-C. I'm going to Alt-Tab back over to here, hit Alt-V, and that should do it. Yeah, there it goes. It's going. I can still see that it looks like we're dropping some, but I think that might be on the way back, not on the way in. So we're just going to let this run and finish, and then we'll double check that it looks correct on the real terminal. All right, it looked like it copied over all right. I'm a little nervous about the fact that it looked like the echo back from the machine into TerraTerm on the laptop wasn't working, like we had some dropped characters. I hope that doesn't mean that we had dropped characters going into the file, but we can double check that on the real machine here right quick by just using the built-in ASCII file viewer. So we'll do s.crt. The file was ZEMU, and that's on 1, and we'll just go ahead and hit enter on that. It's not in a library, and yeah, there we go, it loaded up. So actually going through this, I can see it says format, full line, format, status, format. Those were 2 of the ones that the F had looked like it had dropped off on the echo back going to TerraTerm. And you know what? They look totally correct here. That's good news. So apparently it was just the echo back to TerraTerm was just having a moment. But it seems like it synced it all perfectly. We'll go through a little bit of the pages here just to double check a little more, and we can get a look at Rin's code here. It is wonderfully commented, and you can see that Rin did a fantastic job commenting this. So I'm going to put a link to the full code below, so if you want to dig through the CPL code that Rin wrote for this, it is there to look at, because Rin is just an amazing programmer and he did an awesome job. But as I'm going through the pages here, everything looks like it went in correctly, so I think we're ready to compile this. So I'm going to hit Q to quit out of our CRT file viewer here, and we're going to try and compile this. And we're going to do it with p.cpl emu on 1, and our output device is CRT0. I'm going to go ahead and hit enter, and it's not in a library, so here we go. Oh, that was an illegal parameter. What did I miss? That should have worked. It says illegal parameter. Maybe JCL had a parameter hanging on there for something. I don't know. Let's try it again. We'll do p.cpl emu because it's ZEMU and we want it to, it automatically prepends the Z. It is on platter 1. We want our output device to be CRT0, and that should be the whole thing. In previous episodes I was putting an X on the end, but you don't need it, so we'll try it again here. That time it went. I don't know what's going on. You guys saw it. I typed the exact same thing twice. I have no idea what just happened. The only thing that changed is I ran an s.con in the middle there that should have cleaned up some stuff. But CRT viewer and CED everything should run that already. So I don't know what was going on there. Now it is compiling. It is a very, very long program, so it takes the compiler a little bit of time to run here. So I'm just gonna sit back and let it go, and hopefully it doesn't get any errors. Well, it looks like we're getting pretty close to the end. It's creating a new file, xemu on 1 as an executable. Then it ran the linker. Well, that's what it's running right now. p.xlink is our linker there. Everything looks like it's good. I've never seen a compile fail this late in the stage. Yeah, it just ran scon. We're at the end. Whew. Oh, this is getting exciting. All right, to run it, we're just going to do a .run xemu and then hit enter. That's it. That's the vacuum tube computer being emulated on this machine. Oh, that's so cool. Okay, so on the left side of the screen here, we have an ASCII representation of the actual UE14500 processor. All of the little dots are vacuum tubes. All of the V's are VFDs. Right next to it, you can see we have a representation of the remote. Now, the way that this is laid out is that where the asterisk is set up on the bottom here shows what's selected. And then I use H and L to move my cursor left and right here. And then I use space to toggle something. So my instruction right now is 0000. If I want to initialize the processor, I start with an IEN operation. That's going to be 1010. So I'll hit space on the first one here. We can see that it selected that. We'll go over to, hit space on that one, and we can see now it's 1010. We can see up here it says status, and that says IEN. So it's letting me know that I have selected an IEN operation. That's correct. We'll set the data to 1, so we're forcing a 1 onto the data bus, and then we go over to the clock, and the clock toggles high and low separately. It says that right here on the right. And so if we look at the representation over here, as soon as I hit the clock, we're going to see the instruction light up 1010, and we should see the IEN VFD over here light up as well. And yeah, there it goes. We don't have a bold or anything like that, so he's using an @ symbol to show me that they've lit up. That is absolutely correct. And then we do a 1011, so we'll toggle that one. That's going to be OEN, which is down here. And yeah, we saw that happen. So to finish our initialization here, we're going to go over to a 0100. We're going to turn our data to 0. This is going to force a 1 into the result register. And yeah, it did that there. And then we'll do a load of 0. And I'll go ahead and toggle the clock on it. And yeah, there it goes. We loaded a 0 into the result register. We are fully initialized, ready to go. There it is. The vacuum tube computer is being emulated on the Centurion. That's so cool. Oh, that's so cool. But the vacuum tube computer is way over there. I want to compare this against the computer. But how am I going to get this huge behemoth over there? And it doesn't roll very easily in here, and I've got all the cables set up correctly. I don't have to get the machine over there. I just have to get a terminal over there. And, well, the main terminal that's sitting on top, I can't really move. I cut the cables to the RS-232 cable to the exact length, and it's all snaking through. That one's not going to work, but I have another terminal for the mini Centurion. I can just plug that one into a spare port on the MUX card and run it over next to the machine. And, well, then it's remote access. That's exactly what this machine was built to do. It was meant to have the computer in a closet and all the terminals out in the office. That's a brilliant idea. I'm going to go grab the terminal and we'll set it up. This is going to be awesome. I've got the CRT out, it's hooked up, it's on and working. Right now it seems to be working fine. Every once in a while it seems to get this kind of like wave pattern that goes down it. Sometimes it's non-existent, like right now. Sometimes it's really severe. Most of the time it's really subtle. I have absolutely no idea what could be causing this. So any data terminal, or more importantly CRT experts out there, if you recognize what that is, let me know, because I would love to fix it. And well, it seems to have fixed itself right now, so we're gonna get while the getting's good. I've got it up and connected to the system, showing the status display here. We'll go ahead and run the emulator. We'll do .run xemu, hit new line. Yeah. This is the real thing. There's the emulated version running on that machine way over there. How cool is that? The real vacuum tube computer is on because I've been using it as a heater for the room. So we'll go ahead and initialize it. I've got the little remote control for it over here. So we'll do a 1010, force the data to 1. That should put a 1 in the IEN register there. We'll do the same for OEN down here. And then we'll do a 0100 to put a 1 there. And then we will load a 0 into that. And there we go. The vacuum tube computer is now fully initialized and ready to go. So we'll go ahead and initialize this. So we'll do a 1 0 1 0. We'll set the data to 1. We'll turn the clock on. I can see that it changed the VFD here. We'll turn the clock off. Then we'll do a 1011. Do the same thing for OEN down here. All right, next we'll do a 0100 to force a 1 into the result register. And it did that right there. And then finally, we will load a 0 into the result register. And yeah, there we go. Both systems are now in the exact same state. So let's load 1 plus 1 on both systems and see how they react. So in order to do that, we will do a load operation of 1. So we're 0001 with the data set to 1. I'll push the clock, and when I push the clock down, nothing should happen. When I release the clock is when it stores the 1 in the result register. And yeah, I can see it did that. And then we'll do an add. So 0010, we'll leave the data at 1. Again, I'll push the clock down. Nothing should happen. But when I release it, the result register should go off and the carry register should go on. Yeah, exactly what happened. So on the falling edge of the clock, the addition occurred, or rather it latched the result of the addition into the result register and the carry register. 1 plus 1 equals 2. 2 in binary is 1, 0. This thing is working perfectly. Let's do the same operation on the terminal over here on the Centurion. So again, we'll pop over to a 0001. We'll set our data to 1. I'll hit the clock up. It toggles high-low separately. So when I hit it up, I can see that it did some stuff, but our result register is still low. When I toggle the clock low is when it should store, and yeah, there it goes. All right, now we'll go back over to a 0010, leave the data at 1. Again, I'll toggle the clock on. That's the rising edge. Nothing changed. Well, internally stuff changed. The addition happened. We just haven't latched it in yet. When the clock hits the falling edge, we should see it latch in, which means the result register should go off and the carry register should go on. And that's exactly what happened. Oh, that's really cool. Now I'm noticing that every time I do something with the clock, I can see the cursor fly all over here, updating the VFDs. And I've noticed that on the screen here, it's actually a little longer. And if I look over at the Centurion itself, I can see that the blinking lights on the front are doing different things depending on if it's the rising edge of the clock or the falling edge of the clock. So we'll just do just a simple operation here. We'll load a 1 into the result register. That's going to mark a change. So when I hit the clock here, the blinking lights flash. They do something. So there's some calculation going on, and it lasts, I don't know, about half a second to a second. And then on the falling edge, when I turn the clock off here, looking at the blinking lights, they go for like 1/10 of the time. And that makes total sense because the way that the real processor works is that everything is done on the rising edge except for latching the result register and the carry register. That's the only thing that's done on the falling edge. So the amount of computing that the emulator has to do on the rising edge is considerably more than the amount of computing it has to do on the falling edge. And that's something that we can visually see in the blinking lights. We can see that the duration that the blinking lights stay illuminated on rising edge is totally different than it stays illuminated on the falling edge. That is an amazing visual representation of the type of calculation that's just happening every time I push the clock in the real deal here. And that's something that I never would have noticed unless it was running on the real Centurion. How cool is that? We're learning stuff, and well, we've got a Centurion emulating a vacuum tube computer, which honestly is not too far away from what a minicomputer in the 1980s might have been used for. Now, that's not the use case of the Centurion. It was very much so targeted at accounting and oil and gas and things like that. But something like the PDP-11 would have been used to create emulators and simulations for different chips and microprocessors that were being developed around that time. That is just, oh, that's so cool. So Ren, I want to thank you so much for porting your emulator over to the Centurion. This is the coolest thing ever, and I'm having an absolute blast playing with it and comparing it with the real deal. And oh man, I'm just going to sit down and tinker with this a whole lot more. And I'm going to leave the vacuum tube computer on while I do that because the warmth coming out of it is very much so welcome on a day like today. So I want to thank you guys so much for watching, and I hope to see you in the next episode.